This video is about how the computer actually stores a float, a number with a decimal point. If I were to say float x semicolon, x is a variable of type float, and it's going to take up 4 bytes, 4 storage locations in RAM. If I assign 400.125, the question is, how does it look? Okay, right here are the four bytes. And we are looking at 8 bits inside each of the 4 bytes. And I will tell you now, this particular bit here is a sign bit. If it's off, the value we're storing is positive. If it's on, the value we're storing is negative. In this case, since 400.125 is a positive number, we're going to go ahead and leave this bit off. The next 7 bits actually have to do with E notation. Now, the range of values that a 4-byte float can store range from a possible minus 64 to a plus 63 as far as the E notation. That's the range. Now, that being said, we can only store positive values from 0 to 127 in these 7 bits. So what they do is they make 64 the middle point. And if we move a decimal point to the left, the number of places we move to the left will be added to 64. If we move a decimal point to the right, the number of places we move to the right will be subtracted from 64, and that value will be stored right here. You'll see more on that later. The rest of these positions here are all reserved for the binary translation of the decimal number, the zeros and ones. Let's go ahead and try to do this. Okay. So if we take 400.125, if we convert this into binary, we need to do it in 2 phases. We need to do the phase to the left and then the phase to the right. So if we have a decimal point here, this is worth 1, this is worth 2, this is worth 4, 8, 16, 32, 64, 128, 256. What we've done is turned on the bits so that when we add them together they equal 400. This is the 256 one here. I'm sorry, this one right here. That's 256. This one right here is the 128. And this one right here is the 16. And if you add those up, that's 400. So now we have the 400 right in this position here. As far as the 0.001, what we do is we use repeated multiplication. So we take the 0.125 and we multiply it by 2 because we're dealing with base 2. And the answer is 0.25, which means we're going to put a 0 in this spot right here. A 0 goes here. We take the 0.25 and we multiply it by 2 and we get 0.5, 0.5, which means we put a 0 in the second spot right here. We now take the 0.5 and multiply it by 2 and we get a 1.0, which means we have a 1 in the third spot to the right of our decimal point, and we are all done. So to go back up here, we would put a 1 in this particular spot here. That's our repeated multiplication. Now what do I do with this number? Okay, let's take a look. Let's move it down here a little bit. Okay, so now I have my binary representation of 400.125, and there it is. I take this decimal point, and to get rid of it, I count 1, 2, 3, 4, 5, 6, 7, 8, 9. I move it 9 places to the left to get rid of it. Okay. Now what do I do with that 9? Remember the 64 I mentioned earlier? we're going to add 9 to 64. And in this particular piece, right here, see if I can find this for you, from right here to here, 64 and 9 is a 73. So this is the 64, this is the 8, and this is the 1. I store a 73 in this area. Remember the left one here, this is for sign. It's going to be off because it's positive. This is going to be 73. 64 and 9 is 73. And then what I do is I take all of these values, which now look like this without a decimal point, and I put those in the remaining 24 bits. And now what we have is the entire 32 bits look like this. And this is how 400.125 is actually stored in a float, 4 bytes big, which is 32 total bits.